So as I said, modeling is just a fancy way of saying word problems. So there is no one singular way to do these, but I do have some general hints and tips for you. And the first is, whenever I solve a word problem, the first thing I do is I identify and define my variable. And almost always, it will usually be whatever the problem is asking. If my word problem is you toss the ball in the air, how high does the ball travel? My variable x will be the height of the ball. What is the cost of these items? X equals the cost of the items. How long did the trip take? X equals the time it took to do the trip. So it's usually whatever the problem is going to ask you. Now, the hard part about word problems is setting up the equation. Well, if you notice that your problem sort of follows a particular formula, that's my hint to you. Use well-known formulas. If your problem is talking about areas, hey, through geometry, we know a lot of formulas for areas. If it's a lot of angles and trig, hey, we have formulas for trig. So that's my second hint to you. Try to use well-known formulas because those will usually be the equations we're solving. And last but not least, draw a picture, especially if your problem involves geometric shape. A rectangular building, a wheel travels, hey, wheel, circle. A triangular plot of land, hey, triangles. That usually involves drawing a picture. So again, there really is nothing to teach. It's hard to teach solving word problems, but hopefully seeing a handful of examples will let you guys be able to recognize these better. So let's take a look at an example here. Suppose we had a car rental company. And it charges $30 a day and 15 cents a mile for renting a car. In hindsight, that's probably redundant. What else is a car rental company going to do? You rent a car for 2 days. And your total bill came out to $108. How many miles did you drive? So let's put these hints in action. The first thing I would do is I would scan the question and see what exactly it is it's asking me. And almost always you will be towards the end of the problem. So you scan the problem and it's asking you how many miles did you drive. So that is precisely going to be what my variable is. I'm going to let my variable x equals, and you should probably be specific. Don't just say x equals miles. That doesn't really tell you much. So I'm going to write x equals the amount of miles driven. After you identify your variables, you're going to go ahead and skim the problem and then just extract any numerical or mathematical information. So car rental company, I don't really care, charges $30. Hey, that's a number, so that's probably important. And 15 cents, there's a number here, so it's 15 cents a mile. You rent. Oh, 2 days. That's a number. That's information. That's important. Reading. Oh, $108. That's numerical. That's probably important. So once you sort of extract information, I actually like to take the extra step and actually plot it down, just to get away from extra words. I think one of the hard part about word problems is kids get overwhelmed with the giant paragraph. So rewriting the information away from the words might be helpful. So we have $30 a day, 15 cents a mile, We have 2 days, and we have $108, and that was our bill. And usually you get billed as a total. Now comes the hard part. Once we have identified the variables, once we've extracted all the information, the hard part is coming up with an equation to solve. So here's my tip to you when it comes to equation building. Total amounts are usually on its own side of an equation. For example, if you are given a total, your equation will usually be total equals stuff. Now, reading the story, the information they give us was our bill is $108. Typically, when you go to a store, when you eat at a restaurant, your bill is your total of everything. So I know that whatever equation I'm going to write will probably be 108 equals. So I've already used this information. What I'm going to do next is scan the remaining pieces of information, including your variable. So this X is free game, this 30 is free game, this 0.15 is free game, this 2 is free game. And I'm going to see how they relate to each other. Can I put stuff together? Can I add, subtract, multiply, divide them? And that's why I'm very specific. I don't write just 30. I don't write just $30. I wrote $30 a day. Because it's once you have as much information as possible, I hope it's very easy to see some of these information connect with each other. I mean, doesn't it make sense that something that says a day is connected with days? So now we just use logic. $30 a day for 2 days. What do we naturally want to do with those numbers? Multiply them, right? And when we do that, 30 times 2, remember, this was the total money. 30 was dollars a day times 2 days, so this is money. So the very next thing I should make sure is I have money on the other side. Well, the only other variables we haven't used, or the only other piece of information we haven't used is 50 cents to a mile and X. Well, the 15 cents is per mile. X stood for the amounts of miles. It's very natural to put them together. So 0.15X. And this is money. And since the 108 was a total, in math, the word total tells you to add. Voila. There's your equation. The rest is child's play. The rest is like Algebra 1, solve for X. So that was the hardest part there. Trying to piece together your information into a coherent equation that allows you to solve. Can I assume we're all okay with solving a linear equation? Yeah, so I'm just going to fast forward through this. So 108, that's 60, plus 0.15x. Subtract the 60, that's a 48. Divide out the 0.15, and I think if I remember from the previous classes, that's going to be 320. Right. The only thing I would request, and this is an AZ Merit thing, when it comes to word problems, don't just leave it like that. Write a sentence. And I'm not asking for a complete paragraph. I'm not asking for an essay, but just a sentence that relates to the story. So the question asks, how many miles did you drive? My answer would be, I drove 320 miles, right? So just pretending like you're answering, talking to a friend, right? So it doesn't have to be a big, long sentence, just a quick sentence that relates to the story. Okie dokie? Yep. Now, one of my hints was use formulas whenever you can. We're going to be talking about a whole bunch of formulas in this course, but there are some that you should just know. So one type of formula that might be useful in today's practice is something called simple interest. If you remember from last year, you already know what it is. Okay. Simple interest is a way of calculating, well, not surprisingly, simple interest on a loan. And here's the formula. I equals PRT. I'd probably put this in the example 2 section of your notes. Yeah. Oh, or you can put it on the same page. There's lots of space on the bottom. Your choice. where I equals the interest, no duh, earned, P is the principal, which is an econ term for the initial amount. R stands for the interest rate, so R is the rate. But the important thing about R, it must be a decimal, as a decimal. If kids are going to make a mistake, they usually go, if they say 5%, they plug in a 5. It has to be a decimal. And T is, not surprisingly, time. And the important thing is, it has to be the same units as the rate. And what do I mean by the same unit? Because isn't rate always a percentage? Well, if the rate is, 1% a month, time has to be in months. If it's 5% a year, time has to be years. So whatever your units of time for rate is, that's what T should be. Okay. So anytime you have a simple interest problem, it's most likely going to be this formula. For example, we are in fantasy land now, so you inherit $100,000. Like I said, fantasy land. Who wouldn't want to inherit $100,000, right? No objections? You guys are all heartless bastards. Because that means someone had to die for you to inherit something.
I think we have about money.
Yeah. You inherit, let's hope they don't watch this video. You inherit $100,000 and invest it into 2 accounts. Just watch, they're going to write a new will. Do not leave anything to my son. Yeah. One pays 6% simple interest, and the other 4.5% simple interest annually. You earn $5,025 a year in interest. How much money did you invest in each account? How much money did you invest in each account? Yeah. 50-50, good guess. Not right, but good guess. So again, just follow my tips. The first thing I want to do is focus on whatever it is that it's actually asking me, because that's going to be my variable. So how much money, each account. Each account. How many accounts do we have? 2, so that normally would mean 2 variables. The more variables you have, the more complicated the problem gets. We will eventually talk about 2 variable equations, 3 variable equations, 4 variable equations, but I'll say this, everything in this section, you can do it with 1. How? Well, the idea is, if your problem requires 2 variables, but they give you a total, you can actually tweak it so you only use 1. Well, do they give us a total here? Certainly. 100,000. I know I can't go above 100,000. I can't go below 100,000. It is the total amount. So because in my mind, hey, I need 2 variables, but they gave me a total, I can actually just use 1. So let's go ahead and define our variable. X equals. Well, it's how much money is in each account. I have 2 accounts. I have to make X something. So the 6% account, the 4.5% account, it doesn't matter. What should X be?
6.
The 6% I heard. So let X equals the money invested into the 6% account. I'm going to abbreviate account ACCT. Yeah. Well, normally I would say let Y equals blah, 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 the different variable. But because they gave me a total, I know it's 100,000. I should know that if X amount is invested in one account, then the leftover, then the remaining money should be in the other account. When you want to find leftovers, when you want to find the remaining amount, that's a subtraction problem. So if I have a total of 100,000, and I invest X amount into one account, 100,000 minus X should be the money invested in the other account, the 4.5% account. Then you just keep reading, scanning for the information. 6%, we've already covered that. The 4.5%, we've already covered that. Oh, 50-25. So that's new information. I'm going to write them down. 50-25. What's that? That's the total interest. So scanning the whole problem, I think that's all the numerical information we have. It's time to build the equation. Hey, wait a minute. They gave us total interest. My hint was your equations will usually be total equals. So I have a slight suspicion it's going to be 50-25 equals. Hey, wait a minute. This is talking about simple interest. We have a formula for simple interest. It's right up here. So all you have to do is plug and chug. But we do have two accounts, right? That means we're going to have to do the PRT twice. One for one account, one for the other account. And since this is a total interest, all you got to do is add them together. So let's start with one account. Let's start with the 6% account. So I need the principal, the amounts of money I invested in the 6%. We'll look at these three pieces of information. What represents the amounts of money I invested in the 6%? X times R, the interest rate. Well, it's in its name. It's the 6% account. So you got to put 6% as a decimal times T, number of years. Well, it says annually. It says 1 year. So that's 1. So that's the interest for one account. But I do have another account, so I got to do plus. And then you just repeat the process for the other accounts. How much money did I invest in the 4.5% account? It's right in front of me. 100,000 minus X times his interest rate, which is 4.5% as a decimal, 0.045 times the time, 1 year. Voila. There's our equation. Go ahead and solve it. Question?
Wait, why'd you subtract 100,000 extra 100,000?
Oh, because we know there's only two accounts, right? So if 100,000 is the total, and I put X amount of dollars in one account, then the leftovers have to go to the other account, right? How do I figure out the leftovers? You subtract.
Oh, so you have to redo the whole thing again?
You don't have to redo the whole spiel all over again. Yeah. And then you just go ahead and solve. So it's a relatively straightforward linear equation. I'm going to assume we're okay with it, so we'll fast forward through bits of this. Go ahead and clean this up. So X times 0.06 is 0.06X plus we're going to distribute the 0.045. So 0.045 times 100,000 is 4,500, I think, minus 0.045 X. Let's subtract 4,500 to the other side. So what's that? Is that 475? No. 520. Is it 525? Why can't I do simple subtraction? It's been a long day. 525, yeah. Equals, and then 0.06 minus 0.045 is 0.015x. So 525 divided by 0.015 gives me 35,000. Okay. Again, it's a word problem. Don't just leave your answer like that. Write out a little bit of a sentence. The question asks how much money did we invest in each account, and we defined X as the 6.5 account. So I'll say I invested 35,000 in the 6% account, and, well, the leftovers, 100,000 minus 35,000, 65,000 in the 4.5 account. Okay, so I'll admit that was a pretty long sentence, but you get my idea. So the moral of the story of this example, use formulas whenever you can. If it's a simple interest formula or problem, you have the formula for that. If your problem requires two variables, but you're given a total, you don't actually have to use two variables. if you just subtract from the total. Okie dokie. The last example I prepared is just to showcase my last hint. Right. So the last example says a square garden has a walkway 3 feet wide around its outer edge. If the area of the garden, including the walkway, is 18,000 square feet, what are the dimensions of the garden alone? Right. As if I chose this example for a purpose, as if it wasn't obvious enough. A square garden. Gee, they gave me a geometric shape. Maybe I should draw this out. Who would have thought? So they give me shapes. I'm going to do a quick drawing here. Hopefully I can make it square-like. And then it says I have a walkway around it, so I need another walkway around this square. Right. And even though it doesn't look like it, not drawn to scale, we're going to assume that the contractor who built this isn't shady, isn't some guy you just pick on the side of the road, and he does it perfectly, measures it perfectly. It says it's 3 feet around. Yes, I know it doesn't look like it, but hey, that's what the problem says. So what that means is we should know that this width here is 3, this width here is 3, this width here is 3, this width here is 3. Yeah, it doesn't look like it, but pretend it is. And so let's do the tip. What is it the question's asking? What are the dimensions? So that's the actual question. What are the dimensions? If you did not know, dimensions just simply mean size. Now, they explicitly said it's a square. So we know that the length and width of a square are the same. So when I label this, I'm not going to label both. I'm just going to label one of them. So it's asking us what are the dimensions or the length and width of the square, and particularly of just the garden by itself. So one of these sides here, that's the variable I'm solving for. Now, what is the only information, numerical information they give us? 18,000 square feet. And what does that represent? Area of the garden, including the walkway. So that 18,000, visually, I would not mark this up because it's going to make your paper messy, but I'll just do it for our notes, and I'm going to erase it. That 18,000 represents all of this stuff here. Would you guys agree?
Yes.
Yeah. So when I build my equation, because that's the only information I have to use the big square and not the small square, because the only information they gave me was in relation to the big square. Well, trivial question, how do you find area of a square? This is using well-known formulas. Area of a square. Length times width. Since a square has the same length as width, it's simply side squared. Right? Make sense? So I need to know the length of one of the sides of the big square. And again, I'm only focusing on the big square because that's the only information we have. Well, if you take a look at your diagram, I hope we can see that this portion right here that I'm highlighting, that's my variable x. I mean, that's you just look at it. That's x. So to figure out the whole length here, I need to know what this length is, and I need to know what this length is, the green. Well, according to our diagram, we don't have to do any figuring out. You just use your eyeballs. That those green lengths has to be 3s, because it says it's 3 widths around. Therefore, I am done. The whole length or the whole side of the big square has to be x plus 6.
Sorry, sir. I'm slow.
So then, use well-known formulas. Oh, I know the area of a square is side squared. I have my side, x plus 6. So, x plus 6 squared has to be the area that they gave us, 18,000. And what do you know? It's a quadratic equation. Go ahead and solve it. This one here, we only have one variable, so you don't have to do anything fancy. Just take the square root of both sides. X, go away you. X plus 6 equals plus or minus the square root of 18,000. Subtract the 6, x equals negative 6 plus or minus the square root of 18,000. I know I did say that if your answer is plus or minus, you can just leave it like that. But when it comes to word problems, I actually like decimal approximations. So I'm going to split apart my answer. Negative 6 plus the square root of 18,000. And negative 6 minus the square root of 18,000. The one thing with word problems is we cannot have tunnel vision. That is to say, we can't forget what we were doing originally. And what we're doing originally is solving for x, which according to our diagram is a side length of a square. And using realistic common sense, lengths cannot be negative. So I'm not going to even bother trying out this bottom answer because I know it's going to give me a negative answer, which means it has to be the top portion. So I whip out my calculator, negative 6 plus the square root of 18,000 gives me approximately, squiggle, squiggle, 128.2 feet. Right. But of course, it's a word problem, so give me your answer as like one quick sentence. Answer the question, what are the dimensions? So I'll answer that questions. The garden is 128.2 feet by 128.2 feet. Right. It's a square, so it should be the same. Am I saying that these are the only three problem types you'll see ever in this class? No, but the only way you can get good at problem solving, at word problems, is just to see as many different types as possible, see as many solutions as much as possible, and more importantly, practice as much as possible. So that is 1.7a. Since word problems is sort of tough on kids, I decided to split it over 2 days. We will finish the second half tomorrow.